Now I'm going to start to talk about the cross product. If you remember, we previously we talked about the dot product of two vectors. So if I had a vector A and vector B with angle theta, I said that if we have the dot product of A dot B is going to be the magnitude of A, magnitude of B, and cosine theta. And this one is the scalar. So whatever the outcome is the scalar. Similar to that, we have a concept that we call it the cross product. So if I have a cross product of A times A cross product B, this time it's gonna gives me a vector C, and the magnitude of that vector C is A B sine 30. So this is the magnitude of that vector C. So unlike the cross product, which gives us a scalar, unless the dot product, which gives us a scalar, the cross product gives us a vector. If I have and the magnitude of that is calculated from A B sine 30. This is the magnitude. That because it's a vector, it has a direction, and the direction of that vector, all again, we can find it from the right hand rule. It's like that. So you put your forefinger along the first vector, like here, and then rotate it toward the second, the curly toward the second vector, and your thumb is going to show the direction of that rotation. For example, if I assume A and B, both of them are the plane of the board, so I go from, put my forefinger along the A, rotate it toward the B, and then my thumb shows the C, and this is the C. So if you see that is normal to the plane that the A and B located. Similar to that, if I have them sitting on the X and Y axis, for example, I see it here. So I have X, Y, and Z, and then I have two vectors A and B, for example, sitting here on the, it's going to be A, it's going to be E, B, angle of theta. If I have them sitting on that and I put my forefinger, again, if I put my forefinger along the A and curl it toward the B, it's going to gives me the rotation of my thumb is going to give me the direction of that. So as I show here, A toward B, the thumb is going to be perpendicular to A and B, and the same there is going to be perpendicular to A and B. So let me draw them a little bit different. So assume I have two, again, A and B, both sitting in the X and Y. So the C is going to be perpendicular to both of them, and it goes like that. So if A and B, so the C is going to be like that. So this is the C. So C is going to be perpendicular to A and B. So put forefinger on the first vector, curl it toward the second vector, and then your finger is going to tell you which direction the C is that. For that purpose, is that if we have the A cross B, is going to be the negative of B cross A. Because here, let's again look at this one. If A and B is on the surface of that board, so if I go from A toward B, my thumb is toward outside the board. But if I go from A to B, so I put my forefinger in the direction of B and rotate it toward the A, so my thumb is going to be toward the board. So it's going to be the opposite of if I go from A to B, outside, B to A, toward the board. So they're going to, A and B is negative B, A cross B is negative B cross A. That we can find it. One other point that we need to know that is that what's the value of if I times I, J, and K together. See, the easiest way, one easy way is that assume that I and J and K is sitting like that. And if I rotate in counterclockwise, it's positive. So assume the rotation in the counterclockwise is positive. In this case, it's like that. I cross J is K. I cross J is K. K cross I is J. So I cross J is K. J cross K is I, and K cross I is J. So it's like I cross J. I cross J is K. And J cross K is I, and K cross I is J. If I rotate the other, if I rotate the clockwise, it's going to be negative. So I cross K, I cross K, I cross K is negative J. K cross J, K cross J is negative I. And then J cross I is negative K. So it depends on, so it's an easy way to remember that. And remember that I cross I is equal to J cross J is equal to K cross K, and all 0. So if I cross vector of I is 0. And one more time, so just remember I and J and K are the unit vector along the X. So this is the I, and this is the J, and this is the K. So there's a unit vector along the X, Y, and X axis that we have. Now I want to see how we can calculate this cross vector. We are using the determinant to calculate that. So if I have two vector, again, assume I have the two vector A and B and theta, and I have, this is the AX, AY, and AZ, and this one is the BX, BY, and BZ. Then I can write that A times A cross B is going to be the determinant of we'll have I, J, K, and then we have AX, AY, AZ, and we have BX, BY, and BZ. And to calculate that determinant, the way that we calculate the determinant is that so we go like that. So we go that says I, so it says that I'm going to write it again time the cross B. So it's going to be I choose I, and then eliminate the row and the column that I is there and write whatever is left. So I write I, delete the first row, first column, and whatever is left is going to be this one, AY, AZ, BY, and BZ. Then for the second one is going to be negative. So it's going to be negative J, and then again eliminate the row and the column that include J. So the first row, the second column, I'm going to just delete them. So it's going to be, and write whatever remains. So whatever remains, the AX is remain, the AZ is remain, the BX is remain, and the BZ is remain. Then it's going to be positive K, and it's going to be, again, eliminate the row and the column that the K is in those row and K. So the first row and the last column. So this column, just eliminate that and write whatever remain, which is this part. It's going to be AX, AY, BX, by. Remember, we go one positive, one negative, one positive. If we have more terms, again, it's going to positive, negative, positive, negative. So don't forget that the second one is negative. So first one positive, second negative, third one positive, and we have more. It's going to be again negative, positive, negative, positive, like that. And then if we extend that one, so again A cross B is I, and you know that the 2 by 2 determinant is because we times these two together, and then we subtract from the multiplication of these two. So it's going to be AY BZ minus AZ BY minus these two, AZ BY minus J AX BZ AX BZ. So it's going to be AX BZ minus AZ BX AZ BX. And then the third one is going to be plus K, again AX BY minus AY BX minus AY BX. So this is how we calculate the vector of the vector that is product of A product B. So we have two vector A and B. The cross product of that, we know that the cross product of two vector is a vector, and this is the vector result from the product of those vector A and B.